James Webb makes groundbreaking discovery. For the very first time, astronomers have discovered a very clear sign of carbon dioxide in a gas giant planet outside our own solar system, thanks to the James Webb Space Telescope. It has given astronomers a new level of detail in their observations of the cosmos than any other telescope that has ever been created. What's new is that the planet at hand, or in lens, as it were, is a gas giant named WASP-39 B. Some of the star's light was able to peek through WASP-39 B's atmosphere as it passed in front of its star from our perspective, a phenomenon known as a transit. In doing so, it has prevented certain portions of the electromagnetic spectrum from reaching us from the distant starlight. This is where astronomers can play the role of being celestial forensic scientists, because various chemicals leave distinguishable fingerprints in the electromagnetic spectrum. When they look at these observed fingerprints, they can determine what chemicals cause them. This method of measurement is known as spectroscopy, and amazingly, JWST has a special instrument called NIRSPEC built for just this purpose. In the case of WASP-39 B, astronomers discovered spectral signatures in the infrared region of the electromagnetic spectrum between 4.1 and 4.6 microns. And to everyone's satisfaction, these blips are a reliable signature of carbon dioxide on the planet. What's the big deal about finding carbon dioxide, though? Simply put, finding it is a challenge. Methane and water vapor, among others, have been detected by astronomers in the atmospheres of exoplanets. But finding carbon dioxide has been more difficult up until now. Carbon dioxide has previously only been glimpsed in fragments, but thanks to JWST's enhanced resolution, its discovery was like finally getting to the end of a poem you'd only gotten 2/3 of the way through. Carbon dioxide can be released into the air for many reasons, including biological processes, chemical reactions within rocks, and human industrialization. But scientists can glean some interesting insights from studying it. Carbon dioxide molecules are sensitive tracers of the story of planet formation. So by studying them, astronomers can determine how much gaseous material contributed to the creation of the planet. Webb will make this measurement for many planets over the next decade, shedding light on the process of planet formation and highlighting the special nature of our very own solar system. Now, here's some background of WASP-39 B. About 700 light-years from Earth, in the direction of the constellation Virgo, is where you'll find the exoplanet. Despite having only about a quarter of Jupiter's mass, its diameter is 1.3 times bigger than that of Jupiter. Its high temperature, which is approximately 900 degrees Celsius, may be responsible for some of its extreme puffiness, not like the cooler and more compact gas giants that are found in our own solar system. WASP-39 B has a much closer orbit to its host star. With a distance of only about 1/8 that of the Sun to Mercury, it just takes over 4 Earth days for it to complete its orbit. Luckily, WASP-39 B's orbit lines up so that we can see it edge on, as that is the best view possible for astronomers. Therefore, due to the planet's size and proximity to its star, when it does cross in front of its Sun, it blocks out enough light to slightly dim the star. That slight decline is detectable by our instruments. Finding exoplanets, especially massive ones, through this method is common. That's precisely how astronomers in 2011 located WASP-39 B. The sky survey that astronomers used to find it was called the Wide-Angle Search for Planets, or WASP, hence the name. Because of how WASP-39 B was found, we can also use it as a prime candidate for atmospheric exploration. The JWST's pass was not the first time astronomers had tried to study WASP-39's atmosphere. In 2018, scientists using NASA's Hubble and Spitzer telescopes discovered water vapor on the planet. This is where the ultimate question of potential life arises. But unfortunately, WASP-39 B is not a prime candidate for a life search. It's a gas giant, and since it's so close to its star, it's scorchingly hot. However, the number of cool distant worlds with Earth-like temperatures keeps growing. If such planets exist, this finding bodes well for the telescope's ability to measure their atmospheres. The discovery of carbon dioxide in WASP-39 B is just one of the appetizers of the Early Release Science program, which intends to share JWST's findings to the exoplanet hunting community. So, expect a flurry of new exoplanet discoveries in the coming months. As far as what JWST can see, it's clear that astronomers have only scratched the surface, or atmospheres of these exoplanets, if you will. In some more worrying news for us here on Earth, our Sun has a massive sunspot that could cause havoc for us here on Earth. Click the video on screen to find out more. Thanks for watching.